In Learning Assessment 11.4, we're asked to compute the magnitude of the line voltages at the load. We have a three-phase circuit as shown in the diagram, and we're going to utilize our problem-solving strategy entitled Three-Phase Balanced AC Power Circuits. And step 1 of that strategy says convert the source/load connection to a YY connection if either the source or load is in delta connection. Well, if we look at our circuit diagram, the load is in a Y connection, the source is in a delta connection. Okay, so we're going to need to convert our source over to a Y connection. So if we look at our diagram, for instance, we have VAB equal 208 at an angle of 0 volts RMS. And if we convert to a Y, we need the voltage VAN. And if you remember, the magnitude of VAN is smaller than the magnitude of the line voltage by the square root of 3. And if we look at our set of voltages, for instance, we have VAB is at 0, VBC is at minus 120, VCA is at minus 240 or plus 120. So we know we have ABC phase sequence. And as a result, the angle on VAN is minus 30. And that goes back to our diagram, a phasor diagram relating line to line, and line voltages and phase voltages, or line to line and line to neutral voltages for a three-phase system. So VAN is 120 at an angle of minus 30 degrees volts RMS. Now step 2 says we really only need to know the quantities for the phase A circuit, so we're going to draw a per phase circuit. And since we have a balanced system, we look with balance, we have the loads are all the same, the line impedances are the same, the source voltages have the same magnitude, and they're 120 degrees out of phase, so we can construct a per phase circuit. And there's the per phase circuit for this particular problem. Here we've just drawn the A phase. Here's our voltage VAN. Here's our load. Here's a line, and remember we had to convert this to a Y. We originally had a delta connected source. So now we can analyze this per phase circuit, and we'll calculate the current I little a cap A, and it's going to be 120 at an angle of minus 30 divided by the total impedance of our circuit, 10 plus J4 plus 0.1 plus J.1, and that's 11 at an angle of minus 52.1 degrees amps RMS. Now, our load is the impedance 10 plus J4, so let's calculate V capital AN. So that's going to be our current times 10 plus J4, and that's 118.57 at an angle of minus 30.3 degrees volts RMS. And that's the phase voltage for the A phase of our load. If we want the line voltage to load, we now take the 118.57 and multiply it by the square root of 3, and we can see that we get 205.4 volts RMS.